In this video, we are going to see the defer operation on Azure Service Bus Message and its use cases. This video is continuation to settlement operations on Azure Service Bus Messages in this playlist. So I recommend you to watch them before continuing to this video so that you will get better understanding about Azure Service Bus and the code sample that we are going to use in this video. In this channel, every day I'll be posting videos related to full stack web development and cloud technologies. If you like this type of content, please do subscribe and support me to grow this channel. Now, coming back to the video, we'll understand why do we have differ option. When a receiving application received a service bus message and it doesn't want to process it immediately, because of some special circumstance, it wanted to process the message at later point of time. In this case, the receiving application can make use of deferring option to delay the retrieval of the message and processing it later. The deferred message will not be automatically deleted, meaning if the message is in the queue, even after the time to live duration, the message is still maintained in the main queue will not be automatically moved to deleted queue. This will be useful in most of the cases where we need to follow strict workflow or strict order in processing the message. One of such use cases is order processing system. In this example, e-commerce system is initiating order processor as well as payment processor in parallel. This order processor is a system which will insert the order detail in database and it will generate unique key to refer that order. And payment processor is a system will communicate to external payment system to get the payment successful. This order fulfillment system will take input from both order processor as well as payment processor to complete the particular order. In this case, if the payment processor completed and notified fulfillment system even before order processor, the fulfillment system cannot process the payment processor message until order processor completed and acknowledge it. In this case, the order fulfillment system can make use of deferring option to delay the processing of payment processor message until order processor generating unique key and notifying the fulfillment system. The another use case is retry mechanism with exponential backup. If transient failure is happening, instead of immediately retrying the message, it can delay for some time before reprocessing it again. Now we'll move to the code part to see how deferration works. In our receiver application, immediately after receiving the service bus message, we are going to mark this as deferred one. To do that, in our receiver object, we have a method called defer message async. We are going to call that method receiver dot defer message async. This method will take the service bus message as a first argument on which we are trying to perform defer action. Also, this method will take the list of key value pair as a second parameter. Using this parameter, we can update the existing properties of the message or we can add some new custom properties to the message. These properties will be attached to the message and will be used when we retrieve the message at later point of time. For this demo, I'm going to add a list of dictionary of string comma object, and I'm just going to pass key as simple custom and messages deferred by manual. That's it. This method will try to communicate to Azure Service Bus behind the scenes and it will ask to mark this particular message as deferred one. Once the message is marked as deferred, that cannot be retrieved using regular receive is message async method. So to retrieve the deferred message, we have a special method in our receiver object called receive deferred message async. Write receiver dot receive deferred messages. You can see this method is accepting sequence number as a parameter. So to retrieve this deferred message, we need to store the sequence number of the message somewhere. So for this demo, I'm going to create one variable called sequence number, which will store the sequence number of this message. I'm going to pass this sequence number variable to this message, and this will return the service bus message and store it in a variable. And we'll try to console log what is coming it out. We'll name it as deferred message received. That's it. Now we'll go to our sender application. which will post couple of message. I will go to our Azure Service Bus. For this demo, I have created a dedicated queue called defer demo with some updated properties. Like I just updated the time to leave property to 1 minute, and I just enabled decluttering on message expiration so that I can prove the deferred message will not go to the declutter queue on message expiry. That's it. We'll go to the Service Bus Explorer and make sure no messages in the queue. No message. We'll go ahead and start our sender. Yes, couple of messages are posted. We'll make sure messages are reached. Yes, the sequence number is 2627, and more importantly, you can monitor the state of both the messages are active. Now we'll quickly go ahead and start our receiver application because we did set only 1 minute as expiry time. We'll quickly go ahead and start our receiving application. You can see the message is received and deferred message is also received using sequence number. Now if you go ahead Azure Service Bus and you just refresh, you will have both the message. You can see on the first message the delivery count is increased and the state of the message is also changed to deferred. So now we did successfully defer this first message. Now we'll wait for a minute to let the message expire and see what is happening on this deferred message. Just keep refreshing for 1 minute duration. And meanwhile we can see the custom property what we have added is applied on this message or not. You can see the message property, the custom property what we have attached is added into this message. So when we retrieve this message, this particular key value pair will come as an application property and we can use wherever we want. Yes, now you can see after a minute passed, the deferred message is still in the queue, main queue, but the other message which is not deferred is moved to declared queue for the reason of expired time to live. For this message is also the time to live is expired, but still it is in the main queue. It is not moved to declared queue. This is as per the service bus design. The deferred message will not move to the declared queue by itself. It is the owner's responsibility to consume this message and complete with by using this sequence number. If there is a challenge in saving the sequence number of the message for later retrieval, we have an option. Randomly, we can peek the messages like for top message. We can see receiver dot peek message using. We can see this will give the first message in the queue, and we can use this one to retrieve the sequence number. And instead of directly using it, we can just compare if top message dot state equal to service bus message state dot deferred. If it is deferred one, go ahead and use this one. This way we don't need to remember the sequence number, and we have peak messages using also, which will return more than one message. We can specify what is the maximum number of message we wanted to retrieve in one shot. Maybe we can say 10, and then we can loop through it. We can do the same. Must not sequence number. Yeah, this way we don't need to store the sequence number. We can randomly query the message, peek the messages, and we can identify the sequence number dynamically by using the state. We can identify what is the what messages are in default state, what messages are in active state. That is all I have for this video. Thank you for watching. Please leave your thought in comment. That will definitely help me to improve the content.